We're going to talk a little bit about the relationship between polynomials and their roots and how the factors and the zeros are all related. So before we talk about the relationship, let's remind ourselves a little bit about factoring. I always want to look for a greatest common factor first. And when I factor out a greatest common factor, sometimes I can factor again. So we're going to do it again. I'm going to factor out a greatest common factor. And when I factor out a greatest common factor, I'm left with a trinomial that I know how to factor. Okay, we can do that one more time. I can factor out a 3x, and I'm left with 3x squared plus 2x minus 1, which is something that I know how to factor again. 3x, that's going to be plus 1 minus 1, like this. Okay, so when we want to put a polynomial into factored form, we look for a greatest common factor, and then we get it into what's called the linear factors. So notice all of these factors have an x to the first, so these are our linear factors. A linear factor tells us a lot about the polynomial. It tells us about what's called the zeros of the polynomial. It tells us what the roots are of the solution the solution of the equation. It also tells us what the x-intercepts are. So this little box here is giving us the relationship between the linear factor of the polynomial, x minus something or x plus something, and how if x minus b is the factor, then b is the zero of the polynomial function. It is also the root or the solution of the equation, and it is also the x-intercept. So for example, if I'm looking at this first example up here, letter A, no, let's go down to this example A. If I'm looking at this polynomial that's already factored for us, then I can see that the linear factor is x plus 2. If I set x plus 2 equal to 0, then I'm going to get one of the solutions to the equation. But if I make the y0 here, then it becomes a 0 of the function. So that's how I find a 0 of a function or a solution to an equation, is I factor and then I set each factor equal to 0. And that gives me, the factor is what gives me the zeros or the solutions. And when I look at the graph of a polynomial function, it's also going to give me the x-intercept. So let's go back up. These three things are all the same. The 0, the root or the solution, and the x-intercept are all the same number. So let's look at letter B. What are the zeros? If I want a 0, I'm going to set the y equal to 0, and I'm going to solve for x. So a 0, remember, we learned a while back that a 0 is an x-intercept. So when I'm finding a 0, I'm just finding the x when y is 0. So I'm going to set each factor, equal to 0, and I'm going to solve for x. So I get 0, or negative 4, or negative 5. So I can do that one more time. I can make the y 0, and I can factor out a 3x in this case, which would leave me with x squared minus 1, and then x squared minus 1 would become x plus 1 times x minus 1. So I get 3x equals 0, x plus 1 is equal to 0, or x minus 1 is equal to 0. So my three solutions are x equals 0, negative 1, and 1. Okay, so what do we know here now? We know that a 0 is a root, is a solution, is an x-intercept, all the same number. And those numbers come from the linear factor of the polynomial. So that's why we factor to get all of these numbers. And then we have the factor theorem, which goes with it, that says the expression x minus a is a factor of the polynomial if and only if the value a is a 0. So what that's basically saying is that if x minus a is a factor of the polynomial, then a is a 0. And if a is a 0, then x minus a is a factor. Okay, So knowing that, we can write a polynomial function if we have the zeros. So what is a cubic polynomial function in standard form with the zeros negative 2 and 2 and 3? Negative 2 and 3. So I'm going to write y equals, and then from the zeros, the factor theorem tells me that if I know the zeros, then I know what the factors are. So from the zeros, I'm going to write the factors. So if the zeros minus 2, negative 2, I'm going to write x minus negative 2. But I'm not going to write x minus negative 2. I'm going to write x plus 2, right? And if the zero is 2, then I'm going to write that the factor of the polynomial is x minus 2. And if the 0 is 3, then I'm going to write that the polynomial function factor, would be x minus 3. So then I get my polynomial function in what's called factored form. So this is factored form, but I asked for it in standard form. So what I need to do when I want my polynomial function in standard form is I need to multiply. So I'm going to multiply x plus 2 times x minus 2. So that's going to give me x squared minus 4. And then I'm going to multiply x squared minus 4 times x minus 3. So I'm going to do FOIL here. X cubed first, outer, inner, and then last. Okay, so now I have my cubic function in standard form. So I can do another one like that. I can write a quartic polynomial function in standard form with zeros negative 2, 2, and 3. So I purposely gave you the negative 2 twice because I want you to know that that factor is going to appear twice in this function. So I'm going to write y equals x plus 2 times x plus 2. So those are my, that comes from the two zeros being negative 2 and negative 2. And then the next zero is 2, so I'm going to write x minus 2. So the factor is always x minus whatever the 0 is. And so and then the last 0 is 3. So I'm going to write x minus 3. And then I'm going to need to multiply. In order to put it in standard form, I'm going to need to multiply. So that actually takes a little while. So we're going to have to do a lot of FOIL here. So let's see, I get x squared plus 4x plus 4. And then I have to multiply that trinomial times x minus 2. So I need to distribute the x and then distribute the 2. So I've got the minus 2, excuse me. So I get x cubed plus 4x squared plus 4x minus 2x squared minus 8x minus 8. And then I add my like terms. So I get x cubed plus 2x squared minus 4x minus 8. But then I still have to multiply that times x minus 3. So I actually have to distribute twice again. So we'll just move on instead of wasting time doing that because we all know how to multiply. So then I can look at the graphs of the two functions. So the first function is a cubic, and the graph of it looks like this. So I want you to notice the cubic function has in behaviors going in the opposite directions. We knew that that was going to happen because the degree is odd. I also see turning points in the middle. I see a relative minimum, just reviewing some terminology. Also see a relative maximum. But what I'm concerned here is the zeros. We're looking at the zeros today. So I knew that there was a 0 at negative 2, 2, and 3. So I see a 0 at negative 2, 2, and 3. So when I talk about the zeros, remember, I'm looking at the x-intercepts. So I see that there are 3 real zeros on this graph, and they all go through the x-axis at that value. Okay, and then I can look at the quartic polynomial. The quartic polynomial is right next to it. Notice the end behaviors are going in the same direction because the degree's even. Remember that. Degrees are even, the end behaviors go in the same direction. I also see 3 turning points. But notice I have, how many zeros do I have? I have negative 2, 2, and 3. And I wrote negative 2 twice. I wonder why I had to do that. Negative 2, 2, and 3. So let's see. Negative 2 here, 2, and 3. So notice, since the factor x plus 2 appeared twice, so I had x plus 2 times x plus 2 times x minus 2 times x minus 3. So since that factor of x plus 2 appeared twice, look how it shows up on the graph. We have what's called a repeated linear factor because obviously it's a linear factor that repeats. So we have a repeated linear factor, and it causes negative 2, which is the 0, to have a multiplicity of 2. So whenever one of our zeros has a multiplicity of 2, I want you to look at the graph and notice that the 0 doesn't go through the x-axis. It only touches and goes back up. So it ends up appearing quadratic at that point. It ends up being a turning point. Instead of the other two where they go through the x-axis, this one just touches and goes back up. So when we have a repeated linear factor, then that 0, which in this case is -2, has a multiplicity of 2, and it touches the x-axis but doesn't cross. Okay, so that's what all this is saying here. You can write the polynomial function in factored form. There's a repeated linear factor, then there is a multiple 0. We call it a multiple 0, sometimes known as a double root. You can say -2 is a multiplicity of 2. That's what we just talked about. Okay. And then we can do that one more time. What are the zeros of this function? So we're going to make the y 0 and we're going to solve. So I'm going to factor out an x squared. So I get x squared minus 2x minus 8, which is something we can factor again. X minus 4 times x plus 2. I'm finding zeros. So if I said x squared equals 0, x minus 4 equals 0, x plus 2 is equal to 0, we get x equals 0, 4, or 2. -2, excuse me. But I want you to notice that one of these actually is a repeated linear factor. So instead of writing x squared, we could write x times x, which gives me a repeated linear factor. X equals 0 is going to have a multiplicity of 2. So let's see. We're going to write the zeros and state their multiplicity. So 0, 4, and -2. So 0 has a multiplicity of 2 because the repeated linear factor causes it to be like that. And then the other two have a multiplicity of 1. So if we look at the graph, we notice on the graph that -2 and 4 go through the x-axis, 0 touches it and just goes back down. So the last thing in this lesson is talking about relative maxes and mins. And I'm not going to review this again because this is something we already know how to do. So I'm expecting that we know the difference between a relative maximum and a relative minimum. A relative maximum is the value of the function. It says as an up to down turning point, but we're going to say increasing to decreasing. And then a relative minimum is the value of the function at a down to up turning point. So we're going to say decreasing to increasing. And so when we use our calculator to find the relative maxes and mins, remember we use second calc 0. And when we give it a left boundary and a right boundary.